Hello everyone, today in this case for exploiting XXE to perform SSRF attacks, and this is something that's pretty realistic. If you find XXE in the wild, sometimes you are going through local files and you are not finding a lot, but if the application is hosted on cloud infrastructure, you might be able to leverage this XXE to declare an external entity that forces the application to send a request to the metadata service. So let's get started and dive into this lab walkthrough. So today in this session, we will be exploring how to exploit an XML external entity validity to perform a server-side request forgery attack. So basically this lab will help you to understand how attackers can abuse XXE vulnerabilities to gain unauthorized access to sensitive data like the server's IAM secret access key. Alright, so the main goal for today's lab is to exploit an X vulnerability in the lab's checkstop feature, allowing us to perform an SSRF attack and retrieve the server's IAM secret key from a simulated EC2 metadata endpoint. So basically this lab provides a checkstop feature that processes XML input and returns unexpected values in the response. Additionally, the server simulates an EC2 metadata endpoint at 169.254.169.25 the IP, which could potentially hold sensitive information. So to get started, first of all, we will access the lab and we will wait for the page to open. So our second step is to intercept the post request. So visit our product page on the lab and click the checkstop button. Intercept the resulting post request using burpsuit, a popular web proxy tool for analyzing and manipulating HTTP requests and responses. Now I will send this request to the repeater. So in the intercepted requested, locate the XML declaration and the stock check element. Insert the following external entity definition just before the stock check element, which is doctype test entity test system with the IP address. Now replace the existing product ID number with the reference to the external entity, which is ANTEST. The response should contain invalid product ID followed by the response from the metadata endpoint. Additionally, this response might be a folder name. I iteratively update the URL in the document dive definition DTD to explore the EC2 metadata API. Secondly, keep updating the URL until you reach the path, which is latest/meta-data-im/security-credential/admin. So now the X payload we are going to discuss looks like this. So this payload might seem complex at first, but let's break it down step by step to understand how it works. First of all, we have doctype test. This is the document type declaration DTD for the XML document. So now this is where the magic happens. Let's break it down further. Now we have entity test. This creates an entity name test. An entity is essentially a variable that holds a value. Now we have system HTTP 169.25 for the IP address with the metadata URL. So this is the value assigned to the entity test. It's a URL that points to a specific resource. So how the payload works in the context of an XXE vulnerability, you inject this payload into a vulnerable application's input that processes XML data. So the payload usually goes where the application is expecting an external entity reference to bring the XXE vulnerability. When the application processes the XML input containing the payload, it tries to resolve the entity reference name test. So the SSRF attack begins where the payload URL points to the EC2 metadata endpoint, the IP address. The application makes a request to this URL internally, as if it's requesting information from a remote server. If the application is vulnerable to SSRF, it will make the request and receive the response from this simulated EC2 metadata endpoint, retrieving sensitive information. So the response from the metadata endpoint contains sensitive data, such as IAM security credentials. The sensitive data is then included in the application's response to the user, making it accessible to the attacker. The response from latest metadata/IAM/security credential/admin should be written JSON file with containing the secret access key. And check this out, we have AWS grid, so as an AWS access and secret key. And with these keys in hand, we can send requests to the AWS API as the IAM role admin, which could possibly give us a foothold into their entire cloud infrastructure. So the important takeaway here is what can you do with XXE, and let's perform SSRF attacks and also access local files. So this SSRF doesn't have to just be HTTP, and it could be other protocols too. So that's important to keep in mind. Well, that's all I got for this video. Thanks. Have a good day.